All right, welcome back to the Nix Hour. So as you can see, this month we're gonna do the Nix Hour on Wednesday, 4 p.m. CET. So if you can join there, that's great. I also improved the chat overlay a bit, so should be more visible. But yeah, we're gonna do the continuation of the programming puzzle from 2/3 weeks ago. So we did the Advent of Code day 1 for 2023. And we tried out part 2 with the same code as for part 1, but we struggled. And so I'm just gonna jump right into there. That was Nix Hour number 59. Code is on the Nix Hour repository. Okay, so we have a default.nix here, just to kind of reiterate here. We used rec here for easy testing, so we have lib available and we can evaluate all of these things right inside, right from the default.nix. So for example, I have an alias here, NE for Nix instantiate eval, kind of the easiest way in my opinion to evaluate something. And so we have results, we have test, and we have a full one. Right, and we just exchanged the, I believe we have that with input files, tests, and full, and I believe we just kind of exchanged the code to deal with part 2. Well, let me just read this again. So your calculation isn't quite right. It looks like some of the digits are actually spelled out with letters. Oh, right. So initially we only did the thing with arbitrary alphabets, characters in here, but now we actually need to kind of deal with these 2, 9 as well. And if we just tried it as is, we tried a replacement. So we declared this and said that whenever you see one string, replace it with 1. It's a bit hacky, but I thought that would work, so we did that with replace strings. Let's also use Noogle again, since we did last time. So replace strings. Replace strings takes 2 lists and replaces each instance in the first list with the same index in the second list. And but yeah, this doesn't work because I'm not sure if we have an example in here. So we have these cases where there's 2 and 1 together in kind of interleaved. And so I was able to just think about this since last time, and I think I have a pretty good idea how we could solve this. And I mean, basically the idea is to loop through each individual index in the input. So we go for 2 WO, and then try to match the beginning of each of these here. So in this case, right, we have 8, 2 as well. So we would check for 8 at the index number 0. We check for all the numbers, the index number 0. In this case, it's 8. Go through this, and once we get to this index, we also get the one for T. And at that point, we can get the one for 2. So, but this needs a kind of separate solution, and I don't want to use the previous one, as I'm actually gonna undo this so we can get back the result of the first one. Yeah, 5, 4, 6, 4, 4. Okay, and let's try this kind of anew here. So we have the input files here. I kind of want to reuse because we read already the inputs here. So I'm just going to do not input files, but input strings. Then instead of doing this, I'm going to do a lib.map address. So we have a name of the input and the file. And then for each of these, we are going to do the lib.file contents. So we read the file, and then we split this into each of the lines. Okay, and let's call this input lines. Clear. And also, personally, I like to kind of add a type to these things on top, just for kind of, just for like when you read it back, so you know what it is. So in this case, this would be an attribute set of, I'm going to use kind of the Nix's module system convention of types, address of, and that would be a, well, we can also use list of string, like this. Let's move this down a bit, and then let's refactor this to take advantage of that. So input lines, and we don't need to do this anymore. We can just take this lines. All right, check that this still works. It does. Very good. Okay, and let me also do this results part 1. Results part 1, that's full. All right. Now result part 2. Result part 2. What do we do here? Let's also do the mapping over the, well, let's copy the same from this code here. This should stay pretty much the same, at least the initial part. So we go through each of the inputs. We have hopefully the same test input here. Test input, that's calibration values. Oh yeah, 823, this is still exactly the same. All right, so the test input is still the same. Lines, process line, and then we do the sum, and here the process line needs to be different, I believe. So, how do we approach this? So for each of the lines, process line part 2, let's do it like this. Process line part 2. Maybe let's experiment with the Nix REPL first a bit. So let's say we have a line here, and let's copy this one. So 823, let me move this up here, a bit easier to see. So we have this line, we want to split this into characters. I think that stays the same. So we're going to use string to, oh, we don't have lib here. Let me actually do Nix REPL, load the current file. In here we have lib defined. So lib.string to characters of the line. All right, and now for each of these, so I guess we want to check something for each of these indices, and there may be a number or there may not be a number. We can return null if there's not a number, or we can return an empty list or something like this. Let's say chars. I'm going to say we probably just a IMAP. IMAP map. I think it has to be an IMAP. So IMAP gives you the index of the elements as well. So we get I, we get the char, then chars. All right, and that's not right, char, like this. And now we kind of want to take, takes the first couple elements. So take 2 takes the first 2 elements of this, and it doesn't fail if you go over the length. And so do we want to use take here? I guess we don't actually want to use take here. We want something like if the char, well, not the char, but actually all of the characters after, or including and after this char. So I think we need to use drop, actually. Yeah, so drop is kind of the counterpart to take. If we look at this, drop. No, that doesn't work. I broke it. Let's mess with the URL ourselves here. Okay, next package is manual time. Or is it here? Oh, it is here. Okay. So drop drops the first 2 elements here, and also doesn't fail for if there is no 2 characters. So I believe we want to drop I here. So the first iteration I is 0, so we drop 0 characters, so we get, the entire string. Next iteration, just the one after the first one. So let's try this out, lib.drop. And let's see, we get this. Here the E is missing, here the EI is missing. That seems to work. Okay, now I actually wonder, do we even need to split it into the characters? Because if we use the original, what did we call this, line, we could also do, well, we can't use drop for strings. If you want to use it for strings, we need to use substring, I believe. So substring is built-in. It's a bit, well, that's fine to use. And actually, we're going to abuse it a little bit here with behavior that was undocumented until recently when I made a PR. And that is it exposed under lib? It is. So lib.substring, and we kind of want to do it from I, so that's the first index, and up to the last index, and we can use -1 here. Now you might expect that you have to use lib.string length. Oh, string length, but we can just use -1 here. I need to. Terminal gets messed up a bit with Nix REPL sometimes. So we use -1 here to get to the very end of the line. And let's see, what does this fail? String while a list was expected. Oh, right, we can't IMAP over this. So actually we don't need the character here, so we can also just use lib.genList. GenList, let's look at this, takes a function to generate a list element as first argument and the number of elements to generate in the second one. And so we can just do lib.genList here, remove the character here, we don't need it. And here we just say the length of the string. There's length, but length is for lists, so we need string length instead. String length line. And we get this back. Okay, that's pretty good. Maybe we could put this in here. Let's mess a bit more with it in the REPL. So what are these? These are suffixes. Suffixes. I'm not sure how to spell that. That's suffices. Anyways, so we have the suffixes, and now we need to check for each of them whether they have a kind of spelled out letter as the prefix, or also if there's any numbers in here. Was there an example with 9, 8, 7? Is there one 8, 2, 3, 2, 9? Well, not. Oh, here 2, 1, and there's a 3 here. So we need to deal with both the alphabet and the numbers. I'm actually gonna redefine the line to this one. It's a bit of a better example. Okay. So we have 1 here. Actually, yeah, 2 here. Okay. Now let's do I believe map would work well initially. So we want to do something for each of these. So suffix, and then we say if lib.has prefix. Actually, there's a bunch of different versions of has prefix. Has prefix lists, paths, and strings. I think I mentioned this already last time, but lib.has prefix is for strings, but I like to be more explicit here. Strings.has prefix, and then we need to check for all of these numbers. We can do that with like any. Well, we don't really want to just check if it has a prefix. We also want to replace the prefix. How do we do that? any map. Not quite sure actually. Libdot has prefix. I mean, let's keep it simple for now, maybe. So just 2 for now. So then we get this, but right, we also want to replace it, and so we could extend this like this if it has a prefix 2. Oh, and actually we can also do this, or the first character is a 2 itself. So that would be, well, we also kind of need to use the substring function here. Don't really like doing that. Maybe let's check if there's something else in strings that would allow us to make that better. Oh, element. Oh, I didn't know about this. Oh, no, I think this is for lists. Not sure why. Let's double check here. Element or strings dot element. Let's see foo. Why is this under strings? Wait, string while integer. Oh. No? Hold on. This is weird. Oh, sure. That was not a good time, GitHub. Lib strings, is there really an element? There is. But this is not right. It's exposed from built-ins. Built-ins is the element is for lists, not for strings. So that's not. Wait, this is. Yeah. This is not that good. Okay, thing to fix. So I guess we need to write this kind of ourselves. It's very simple. We can use the substring one. But let's do this here. If has prefix 2 or lib.strings.substring. Now let's use substring like this. 0, 1. So we take from the 0th element and 1 long suffix. Then, and this is a bit. The next repl is not that great now anymore, since we have a bit of a longer input. Then we say we return a list of 2. And else we return an empty list. So this kind of allows us to, well, in the end, let's double check here. Oh, right, equals 2. So in the end here, we get a list of lists. But if we look at these a bit more closely, and I'm going to use Control A to jump to the beginning here. Control E is to jump to the end. These are Emacs shortcuts, I believe. I don't know any others, but this is fairly useful. And so now we get 2 here. And if we were to do the same for the other numbers, so 8, where is it? X, 2, 1, 3, 4. Oh yeah, there's 4 numbers in there even. We should also get that. So let's say 4. Let's do this very manually for now. Oh, yeah, we don't want 2 in this case, we want 4. Then we get a 4 in here. Okay, let's copy this code. And actually, I have this other code up here. This one that I also want. So we have the line. Let's flip this up top here. So we say the suffixes is this. So genlist substring -1. That looks correct to me. Let's return null for now. We could find first number keyword value that is a prefix of the string. Let's check this. I'm not sure if find first. Yeah, find first is for lists, so we'd have to turn it into. Maybe that's fine. We'd have to turn it into the character list. But yeah, maybe let's read up on this bit here. Find first. So yeah, list find first and find first index. And right there we can provide a predicate. And here we could do the thing where we say yeah, check for the both the alphabet and the numbers. You would find first in the list of key values of the number map. Oh, find first. Yeah, that could also work. Yeah. So right, we'd try to find first for any of these. Yeah. Let's actually also do so. In this case, we have the mapping from the strings to integers, and well, before we do that, we actually let's do this in here. I'm gonna try the approach that I have envisioned here for now, but I might be able to get back to the other one. So filtered, maybe like this. Actually, this is not filtered. This is mapped. Let's call it that for now. Oh, and actually, before we do that, so here we have a map, but we actually don't care about all of these. We really just want to concat this afterwards. We can do, there is lib.concat lists, which we can use. This would give us the result of just the one we care about. But there's also, so concat lists and map, that's the same as lib.concat map. So that allows us to save a bit of, I think it's faster because it's actually built-in concat map. Yeah. On concat lists is also built-in, but then you call two built-ins instead of one. So this is a bit better. Okay, let's make this a bit more readable. Oh, split it on the equals. That's why it's so weird. Okay, like this. Oh, and actually, yeah, maybe that's good. Good opportunity to call out. So the RFC 166 to standardize the Nix formatting is approaching FCP very soon. I'm a co-author, and we recently the finishing sprint. And so if you're interested in just checking it out, and I should really also install it myself, though it is in flux, we keep doing changes here and there. You can now use it from Nix packages. So that's the attribute you can install. And maybe I should be an example here. Let's do this myself here. I'm going to get this one, and I'm going to use Nix packages unstable here. It's an easy way to get the current channel. Well, it has to download it now and unpack it. So let's probably continue down here. Okay, so mapped, and so now we need both the 4 as a string and the 4 as a the 4 in with characters and the 4 as a number as strings. Let's do this later. And so we don't just need this, but also, I mean, probably we can do something like, so number replacements kind of full, let's call it that for now. So we want all the number replacements from the characters, but also we're going to do a lib.map attrs prime. So this is a version that allows you to influence the name of the attribute as well. So normal map attrs, if let's try it here. And actually, let's format this a bit better. Oh yeah, formatting. Right, we have it available now. So let's actually, well, let's write this final thing here. So if you do map attrs, we kind of want to say that the name here, well, we kind of want this 6 equals 6 as well. This would be a kind of easy way to do all of the mappings in one. So yeah, we kind of want the name here, but we can't set the name here. So that's why we need map attrs prime, which allows us to set a name value pair. We can do this. So name value. Here we can also set name value. So if we just did this, we would propagate the very same thing and nothing would change. number replacements, like this. And I mean, we can also use inherit here. Actually, we're not going to use it in a little bit. But yeah, the name here, we want the string of the value. So the value here is the number, and now this is the string representation of the number, and that should become the new name. Okay, and instead of doing this name value thing ourselves, there's also lib.name value pair to string value and the value itself. I don't need to merge these. I mean, I feel like it might be easier if I do merge these. Since, I mean, let's try to figure this out. So suffix we want to check for any prefix, and so let's do, actually, yeah, we can use find first here. So find first, actually, there is find first, and there is find single. So find first, I guess, in this case, it shouldn't be a problem, I hope. Yeah, it's not a problem, because there can only be one match. But if you could have multiple, so I guess if we had like 5, I don't know, 5, 8 here, it doesn't really make any sense. But both of them could match a 5 suffix. But in this case, I guess it doesn't matter, so we are going to use find first. So lib.find first. Now here's the predicate. So that is, and actually this is an attribute set. Find first needs a list. So maybe we should actually convert this to a list. And replacements full list, maybe? Actually, okay, let's call this one full. Still haven't formatted my code here. Number replacements full list. Our variables are getting longer. Don't really like that. But we're gonna do lib.map address to list. This allows us to turn an attribute set into a list, and we need to give a function which tells it how to convert the attribute entries to list elements. And so in this case, I think we can also just use name value pair actually. So we just want a name value pair, so we can check for both. So name value pair, name value. Actually, this is, if you know a bit of I guess lambda calculus or functional programming, you can query this argument here, or both of them actually. So we can just do this. That's nice and short. Okay, and actually let's just double check here before I code too much. Number. Oh, I have an error here. Oh, that's fair. Why is there an error? Oh, I have the find first here. That's fair. So number replacements. So here we have these full ones. We also have the numbers. That sounds good. And full list. Well, we need to add strict, so it evaluates the things as well. And yeah, now we have name, value, and each of the kind of replacements. That sounds pretty good. So find first, we have the, oh yeah, let's maybe start with the last argument. It's a bit easier. So we have 3 arguments. This is the default. Let's do this. Actually, the default should be this one probably, yeah. Or null, I'm not quite sure yet. But yeah, we want to match over these number replacements full list. Let's comment this out. And so we have the, in here, we take the kind of name value pair. But I'm just going to match on this. So name, comma, value. All right. And now we need to check if the suffix here. Actually, yeah, we have the code down there. Strings that has prefix. So we want to check for name as prefix, and actually let's, well, we have, it's called name because of the name value pair here. If we want to change this attribute name here, we'd have to change, we couldn't do the nice call here. So yeah, let's just keep it like this. Has prefix name of the suffix. Okay. And actually that's it for that. Okay. And what do we get back out of here? So we get the first entry, so it will be either something like name value or this here. And maybe null is better here actually. So we can do something like this. Let's call this the match. All right. List in. And now if the match is null, then we do an empty list. Otherwise, we do the match dot value. All right, and I believe that oh yeah, value equals null. Yeah, we could do that. Equals null. Yeah, that sounds actually pretty good. Well, actually, we still need to handle the case of returning an empty list. So this here would return a null. But we can. No, it doesn't quite work. Let's keep it like this for now. We can do lib.optional. Optional. Yes. Optional. Let's read up on this. So optional takes a boolean and a value. If the boolean is true, it puts it in a list. Otherwise, it doesn't. Fairly simple function. So optional match not equals null. We want to put the match.value into a list. Okay, and now let's just return mapped here and then check the intermediate result, and that should almost be complete now. Can occurs an integer to a string. Let's see, where does this happen? Find first has prefix value find first. Maybe, okay, let's try this a bit better. Show trace. So it happens in here. That's not very helpful because it doesn't actually show us the location where it happens. 72, yeah, that's just here. Let's maybe go a bit further up, although I don't think going up here actually helps in this case. Okay, so can occurs an integer to a string. Where does that happen in this function? We've mapped concat map. Well, maybe let's try out the find first in the REPL actually. Let's do next REPL. Let's also load the current file. And now the REPL gets a bit messed up, though I think it should work if we just copy this part here. Well, it doesn't seem to. Undefined variable suffix. Right, we still haven't formatted our code. But yeah, suffix, foo bar. And that seems to work, although it's not that great. Let's copy the match as well here. Okay, match, that doesn't work. Yeah, it copies them individually. That's not great. Can I do some Vim magic here to get rid of the new lines? I think I can, yeah. Okay, find first, that's a null. Okay. What about the suffix being 1, 2? Okay, I mean, that seems to work. 1, 2, mapped. Oh, this is not a... It doesn't return... Wait, it doesn't return a list. Oh, no, that makes sense. So match not equals null. Let's see, so we have either null in this case, or it's not a null. If match is not equals null, then... Oh, okay. Another problem here. We don't return a list in this case. No, that we should return a list in this case. Okay, let's do this again. Oh, I did mess up my undo. That's fine. Let's redo this one. Yeah, this I don't really like doing this, but I don't see a better way to just get to code from into the Nix REPL. We can use the debugger, although I'm not. It has some problems. So match, and then let's try this lib.optional. Match not equals null, match dot value. Okay, and now what if match is null? Then it's an empty list. That seems to be fine. Okay, let's debug this like this. We're gonna call this function directly. It's an empty line. Seems to work. 1 seems to work. 1 1 seems to work. 1 2 that also seems to work. What is the example here? This one. 2 1 3 4. That also seems to work. We should trace the line that we're processing. That is a good idea. Let's do this here. Now I need to know the tracing functions. We want sec because we don't want to return the element directly. I'm also going to use sec n. We can use sec directly, I think. And let's print the line. And then call result part 2 dot test. Scroll up a bit here. Trace 0. Is that the actual line we're printing? Line. Let's do this. Now it's not here anymore. That's weird. Trace 0. Oh, the line itself is a number. That is not great. Hold on. So we have input lines dot test. No, that doesn't seem to be it. String. Results part 2. Yeah, it sure does look like that's an integer. Maybe let's also print built-ins.type of the line. Yep, that sure is an integer. Okay, process line. Let's look at this here. Oh, well, here's the problem. We do an IMAP in here, so we get the integer as well. That explains it. And now we get some other problems, but that's from later down here. Just comment this out for now. All right, that works. Yeah, debugging Nix is not very fun, to be honest. Anyways, so we have process line part 2. And now what do we get back? Test. Let's print this. Okay, now we get these. How did we do? So now we have kind of the same thing we had for part 1. How did we do the last thing here? Oh, here it is. So let's just copy this. I can put it in here, I believe. Actually, I think no, I have to put it in here. Maybe we should also use the built-in stuff, the lib.pipe here. Let's do that. Lib.pipe. We are going to pipe the line, and the functions that we have are the suffixes. All right, so we have gen list. It's kind of our first input. We could do it like this. We could do string length here. String length and then gen list. It's a bit weird, but we can do it like this. Then we have this long function. Let's put this in here. All right. And finally, this one. Okay. Probably a bunch of things are not right now. It's a lip-top pipe. Let's just test it again. Yeah, that seems to work. Previously we had 2983. These are the first and last numbers. And now we just need to sum this up like we did with the previous part. Like this, 281. Let's see, 281, that seems to be correct. And let's check the full input. 83348. Second try. That's the right answer. Very nice. All right, so we struggle a bit with the debugging there, but figured it out in the end. Let's maybe simplify this a little bit or try to improve the code quality. So tracing pipe, we trace the lines here. Let's actually remove the tracings here. Don't really need these all the time. We could also do something where we only trace if we need it, but let's not do this for now. And maybe this is actually a good opportunity to show the relatively new debug trace built-in, or trace debug, trace verbose. Here it is, trace verbose. So it's kind of like built-in .trace, but it only traces stuff if the -- trace verbose is enabled. It's actually, I think we should do that. So let's change tracing pipe here. This could probably also be improved. But instead of doing the built-in .trace here, we use trace verbose. Okay. Now let's do this here. Result part 2. Full. Okay, we don't get any trace here. What if we do trace verbose? We do get the line. Well, the entire input here actually. Probably don't want to use trace pipe here though. This is not very easy to see. So what if we do? Oh, actually we have this in here. We don't want this. It's a bit weird. So let's not do the tracing pipe here. Let's be a bit more explicit about what we want to trace. So if we just have this, nothing is traced, okay? Now we probably want to trace the individual lines. So I guess we can insert this here. Built-in .trace. Actually, well, we can. We'd have to add a line here. Line, trace verbose. Do that. Yeah, this is what? Lines. Oh, right, this is a list. So actually we don't want this. We want to trace the individual items. So let's put this in the process line part. This is where we do the mapping. So here at the beginning, and here we don't need this here. We can just do this. All right, that looks pretty good. Now we can remove this I here and change this to just a map. Map is not available in lib, so we have to do this. Very weird. Still need to do a PR to fix that. Still works. And actually now it might be a good time to use the formatters. So the package is called Nix FMT RFC style. That's because originally the code base is the same as the one from Nix FMT. The style is completely changed though, so it's very different from Nix FMT. But the command is also Nix FMT. Might be changed in the future, but for now we're just going to call that, and I'm going to do that on the default.nix. And now, I mean, it looks okay. I mean, you feel free to check out the RFC if you want to be discussing the format more explicitly. Anyway, so can we do any other improvements here? And actually, this is one of the things that has been just suggested recently, to do it like this instead. And actually, this was changed. It just hasn't made it into the Nixos unstable branch. But okay, so libtal map. I mean, that looks pretty good to me. I guess here we don't need this name. There's a kind of odd, well, in Haskell, for example, if you do this, you can ignore the variable name, and you can't even use it. In Nix, it's a bit different because this is valid variable name, so we can say underscore equals 10 and then refer to the underscore. Very weird, but it is kind of a signal that the argument is ignored here. In this case, yeah, it's fine to ignore it. I wonder, we don't really need to do much else here, probably. Process line, we have pipe, trace, string length. I'd probably change this, but that's fine. Concat map, name value, we have the match. This could be put into its own function. Find first. Oh yeah, I guess efficiency would be another point here, actually, yeah. So if we evaluate this, this takes a couple milliseconds. Let's actually do a Nix show stats equals 1. So this then prints some stats on the Nix evaluation. And in particular, one of the most interesting bits here is GC total bytes. This is how much memory it had to allocate. And we could reduce genList to string length -3. What is the -3? Oh, that might be a smiley, maybe? Not sure. genList. 3 characters. I'm not quite sure how do we get to 3 characters? I see. The shortest name of any number is 3 characters. Well, but we also have the we effectively check for also 6 equals 6. So we also checked for these entries, and these have only 1 length. So I don't think we could do that. But yeah, that's an idea. So gc.totalBytes, that's the number of bytes it had to allocate. In this case, we have 266 or 67 megabytes, which is quite a lot for not actually doing a lot of things here. So we can also pipe this to a file with Nix show stats path, I believe. Stats.json. Yeah, stats.json. And oh yeah, 400 milliseconds is not very great. There's some ways of looking into what Nix exactly does underneath. I haven't experimented with those too much, but one of them I think is trace function calls. Well, you can't really do much with this kind of input here. It's very, very rough, and I can't seem to stop evaluation now. Oh, and actually that might be fixed now. There's been an issue recently that's been fixed that you can probably interrupt Nix when it does this kind of thing in your versions. I'm gonna have to resort to like a sig term here, or sig kill actually. Is this the right one? Yes. Okay, we stopped it. There is, what if I search for flame graph? There is something for that, and actually there's this discourse post here. Let's see if that shows anything. Okay, oh yeah, flamegraph.pl. We could try that. I was hoping someone could link to more stuff, but maybe we could try this one. So next function calls work here. Next instantiate traces function calls, outputs the trace. Then it does a stack collapse. I don't have that. Next gets stack collapse.py. Oh, this is a Nix itself. Right. So in the Nix source code itself, we have contrib and stack collapse. Yeah. Oh, and there's it's this. Okay. Guess I found it. Let's try this. So I guess we need this available somewhere. I guess I have this here. Nix contrib stack collapse. Okay, that's in my source tree. To be used with this, so Nix instantiate trace function calls, we output this to a file. Let's do this. Trace function calls, or Nix function calls.trace. Then we do the stack collapse. This should really be bundled into a more convenient way to run it. We can also see it takes a whole bunch longer. Expectedly, because it needs to trace everything. Actually, this could get pretty big. Let's just see the file size evolving here. Oh yeah. 600 megabytes already is the trace long. I didn't expect it to be this long. Okay, we have it finally. Next function calls a trace. Can Vim open a 1 gigabyte file? Should be able to, yeah. Maybe let's just briefly take a look at how this even looks like. We have when a function is entered. How do we do this? Maybe up here. Like this. Okay, function entered, we have in the file line 2. So that's up here. Okay, so I guess that's column 9. Entered this. So I guess this is entering the import function itself. The next one is 16 on the same line. So that's Nix packages here. I'm not exactly sure what this means actually. Because this is not a function. It might be something function arguments, might be importing the file itself. Let's see, Nix Hour, do we have any others here? Let's go down a bit. Nix Hour 59, default on Nix, line 60, character 55. So right here is, okay, that's a toString. Okay, that's good enough for me. Don't really need to look at this manually. Let's try out the stack collapse here. And source Nix contrib stack collapse and fold it. I hope that has a shebang or Nix shebang. It does. Very nice. It's not pinned though, so you could get different results. You'd have to add like a dash uppercase I here. Well, dash uppercase I Nix packages equals and then some pinned version. But yeah, let's just wait for it here. How does this look like? Folded. Another big file. Oh, this is 4.6 gigabyte. Oh. Okay. Don't want to wait forever. So let's do the Nix shell call for flamegraph. Actually, what is flamegraph? Let's use search.nixos.org. Flamegraph. Here. homepage. Okay, so that is the thing that generates this. Sounds pretty good. Not sure if that's like being updated and being worked on. But okay, I see here we have these numbers. I'd imagine these are how many times the function is being entered or something like this. Yeah, apparently that's a big package. Maybe I could try something here. So this is being substituted from the cache, which means it should be in the Hydra database. And you can search for store paths up here, but it doesn't work half the time because it times out. But we can give it a try and see if we get it. If we get it, we can get to which build actually produced, like which Hydra build, which Nix packages produced this file here. Yeah, but this is, it's not, oh, it's just really slow. It's already downloaded, I'm pretty sure. Yeah, I don't see it downloading anything else. But yeah, we are just waiting on two things now. Okay, yeah, internal server error. I guess we can get it. Let's see what it actually is here. Yeah, canceling statement due to timeout. Yeah. Hydra, yeah, don't want to look into that. But maybe we could check the issue tracker real quick. Hydra is not super often maintained. Actually, there's some recent news with Hydra, I believe. And I think John Erickson might be working on getting CA derivations to, well, John Erickson, I think Delroth as well, I heard, was working on getting CA derivations to work in Hydra, which might improve a lot of things. But yeah, for now, we're just waiting for this still. We have a couple more minutes here, so I'm hoping this completes. And otherwise, I'm not sure if we're going to continue with the puzzles here. It is probably the most fun to do, the puzzles, but it's not very practical. Well, if you need to know the kind of lib, like what lib provides in Nix packages, it's good for that. But you've kind of seen it at some point. Lib isn't that big. Really, the biggest part for Nix is really all the packages. And yeah, I'm not really sure what to talk about until we have this completed. I hope it completes until the end. Let's just check the resource usage here. Oh yes, this is it seems to run single-threaded. We can run S to attach the to see what is going on. But might be a sub process. So Perl, this one, it seems to be this one. It doesn't seem to be doing anything if I look at this. Or do I need to run it with sudo htop? That shouldn't have to be there. Oh. Perl. Yeah, nothing's happening here. I do see the processor kind of churning though. So, not sure. Well, actually, that's OBS. Maybe. CPU. Oh, it's done. Very nice, just in time. And let's open it in Firefox, which is a decent SVG viewer. And wait, is this all? Wait, this is all we waited this long for. Is this any? Oh, okay, we can dig down a bit. It's not that impressive though, and I'm not quite sure how to interpret this column. Well, probably you want to get the largest one down, and 50, line 50, 85. Well, I mean, that's kind of obvious. Trivial.nix 63. I'm not sure if we can look into this a bit more than that. Trivial.nix, what is it? 63. Oh, I have a different version in this case. Might be pipe though. Anyways, I hope we can cover this a bit better in the future. It would be really interesting to know how to improve performance of Nix code. But for now, I think we need to wrap up. And but yeah, thanks for joining and see you next time. Goodbye.